Hello everyone! In this video I'm going to start talking about animation. I won't be focusing on the history of animation, its genesis and development, even though there are interesting things as well, but I'll try to explain some of the basic concepts, such as keyframes, interpolations, timing and spacing. One of the essential concepts in animation is keyframes. A keyframe is a frame that lets the viewer know what exactly the character is doing. They are the main points of the animation. For example, if you are making a picture series of some physical exercise, then you'll probably depict the most important moments of this exercise. For example, an exercise in squatting. From the standing pose to the sitting pose. These are two crucial poses of this simple exercise. You can imagine the rest on your own. But when an exercise involves some additional actions, for example, you need not only to squat, but to lean to the side in the process, then you'll need at least 3 pictures. And for the third one, it is better to pick not some random middle pose, but the most important one. The one that shows exactly how and in which direction you should lean. So, every time you need to add some important characteristic to our motion that viewers won't be able to imagine on their own, we need a keyframe. And one of the main tasks of the animator is to find those poles of importance in various motions. There are different types of keyframes, and they can be named differently. For example, there are the main keys. They answer the question of what the character is doing. Let's say the character opened his fist. And then there are breakdowns. Breakdowns answer the question how exactly he's doing it. For example, here are some animations that have the same main keys, but a different breakdown in the middle. The other frames that are between these important points in the animation and represent intermediate phases are called in-between frames. We'll cover this topic in more detail later, when we're creating animations. For now, it is necessary to touch on a few other very important concepts: timing and spacing. Timing is the duration of the action. This is when the main actions will happen and how long they will take. For example, here are two animations of the same action, moving a cube, with different timings. Spacing is the change in speed during the action. That is where the object will be in each frame of the interval. For example, here are several animations with the same timing but different spacing. This cube moves at the same speed, and the distance between its positions in different frames are the same. This motion is poorly suited to animating living characters, because it looks very mechanical. In fact, even cars don't accelerate and stop immediately. And this cube moves slowly at first, so its positions in neighboring frames are close together, then it accelerates, and then it slows down again. This is called slow in and slow out. The third cube has only slow in. It picks up speed and then stops abruptly. This can happen if, for example, it hits a wall. However, it's best to learn by doing. Let's create this simple animation. I'll take the scene with the cube again. Under the viewport, here's a timeline, on which the animation frames are displayed. By default, there are 100 of them in the scene right now. The current frame is marked with a red indicator. You can move it with a mouse or use the A and D hotkeys to move one frame forward or back. Keys in Cascadeur are special frames in which the positions of objects set by the animator are saved. Right now in this scene, there is one key in frame 0. It is colored blue, and this key now stores the initial position of the cube in the middle of the scene. If I change this position, the new position is stored. Select all the points of the cube and move it sideways on the z-axis. If you go to a frame where there is no key and try to change the position of the cube, the changes will be discarded. Therefore, it is always necessary to make the frame a keyframe first. This can be done by using the key button or the F hotkey. For example, let's create a new key in frame 40. Next to the key button, there is a small letter A. This is the auto key mode. If it is on, then a key will be created as soon as you try to move an object. I recommend that you do not use this mode yet, because there is a risk of accidentally making a lot of unnecessary keys. The fewer keys, the better. Unnecessary keys can be removed by pressing the same button. Now go back to the key you just created in frame 40 and move the cube forward. So we have two keyframes. That is two important events in the animation. The cube was here and then ended up here. But you can add another key in the middle and specify exactly how it moved. Let's say it would be the key in frame 20. And to understand how to position the cube in this frame in relation to other frames, you can turn on the Ghosts mode. I select the display mode on the previous and subsequent frames. And also, it is necessary to enable the display just for keyframes. Silhouettes appear, which show where the object is. And now I can easily understand where to put the cube in the new keyframe. Move the cube in the middle of the scene. Now select the Y-axis and raise it above the ground. So we have two main keyframes that tell the story that the cube started its journey from this point and came here. And one keyframe is breakdown. It shows that the cube jumped straight forward, not just rolled on the ground. Important keys can be marked on the timeline with a mark button. This won't affect the animation in any way. It's just make it easier for you to see them and distinguish them from the rest. By the way, I have now set the final positions of the object first, and then selected the intermediate. This way of animating is called pose to pose. But you could also create the first key first, then the second, and then the third, each time based on the previous position of the cube. This way of animation is called straight ahead. Both of these methods work, and it is up to the animator to decide which one to choose. In this case, I was more comfortable using the pose-to-pose method. But now let's try to play the animation. The player buttons are on the right side of the screen, above the timeline. There is also where the time of the animation is displayed. Now the cube just jumps abruptly to a new position, and in all frames until the next key, it will just remain in place. So let's calculate its intermediate positions. To do this, you need to set the type of interpolation. Select the interval of frames. To do this, move the mouse over the timeline by holding down the left mouse button. Open the Interpolation scroll menu and select Linear. The timeline frames between the keys are now colored beige. And now, when I play it, I can see the cube gradually moving to its endpoint in the next key. The computer simply drew a line between the two cube positions and divided it into even segments by the number of frames between the keys. This is how the intermediate positions were calculated. You can easily visualize the trajectory in the software. Select the center of mass point and select the frames on the timeline. There are points that indicate where the center of mass was in each of the frames you selected. By the way, so that the manipulator does not obstruct the view on the trajectory, you can hide it by turning on Highlight mode. This is the Q hotkey. The trajectory tool is one of the most useful for the animator. I see the trajectories for those frames and objects that are currently selected. If I select another point of the cube, I see its trajectory right away. If I click on an empty space and thus cancel the selection, the trajectory disappears. But if I want to continue to see the trajectory of the particular point, it must be fixed. So I select the point I want to track, and now I need to click the lock icon. Now I can click anywhere, I will still see the trajectory of the point I want to track, until I press the lock button again. And the same logic applies to frames. Right now, all the frames are selected, and I see the trajectory for all of them. If I select only half of frames, then the trajectory will be displayed only for them. And if I want to go to any particular frame, I will no longer see trajectory at all. In this case, you should first select all the necessary frames, then press this button. Frames with fixed trajectory displaying will be marked. Now I can choose any frames. The trajectory will still be displayed for those frames that have been fixed. Let's get back to animation. So, the interpolated frames are the frames in which the position of the object has been calculated automatically. They are calculated primarily on the basis of the position of the object in keys. But there is also different types of interpolation. With the linear type of interpolation, objects move in straight lines at the same speed. The spacing is smooth and the motion looks mechanical. Now select the frames of the animation and set the Bezier interpolation type. The trajectory of the motion immediately changes. With Bezier interpolation, object moves in arcs with acceleration and deceleration. So we have a spacing of slow in and slow out. You can see how points in the trajectory gradually become farther and farther apart. This is the acceleration. The shape of the Bezier curves is determined by the tangents. If you have ever used the pen tool in a graphic software, you can roughly imagine the logic of building these curves. By moving the cube in this way, I can change the speed of the cube at intervals and the shape of the trajectory. It took 21 frames to get to the middle. Now it has barely moved, even though half of the animation has already passed. That's why its speed is low at the beginning, and the trajectory points are close to each other. But between the second and third keys, it needs to go the rest of the way in the same amount of time. Accordingly, it needs to move faster. However, it will still speed up at the beginning and slow down at the end of the animation. The closer the keys are, the more they can influence the shape of the curves. One of the tricks that can be used to control tangents is to create double keys. Changing the position of the object in one of them will greatly affect the trajectory in the next interval. In this way, you can, for example, remove the slow out effect if you made a double key at the end of the animation and manually set the object so that the speed doesn't decrease. Now let's return the cube to its original position. You can press Ctrl+Z to undo the action. Now I will try to change the number of frames between the keys. This can be done with the plus and minus hotkeys. Select any frame between the second and third keys and press minus. The trajectory is similar to the one we got earlier, but the total animation time has changed. You can also change the timing in another way. First, bring everything back with Ctrl+Z. Now you can select the key in the middle. Click the mouse wheel to make a yellow frame appear, and then move the key to a new location, for example, closer to the last key. Now the total animation time has not changed, but the time of each interval has changed. Note that there is so much time for acceleration on the first interval that the cube has even begun to move backward. In this frame, it's farther back than in the very first key. Sometimes this effect is undesirable. For example, when animating walking and jumping, the character's feet may get under the ground. But for such cases, there is another type of interpolation, Bezier clamp. In this type of interpolation, objects still move along arcs, with acceleration and deceleration, but the object never goes further than it was in the keys. But the junction between different intervals can also be sharper with this type of interpolation. So, these are the main types of interpolation. You can set different interpolation types for different intervals. The interpolation type will be set to the interval between the keys in which a frame is selected. If a key is selected, the interpolation will be set to the interval after this key. Finally, there is another special type of frame, fixed interpolation. Fixed interpolation works the same way as if each frame were a key. That means you can change the position of the character in each frame manually. And also this interpolation will not recalculate when keys change. This type is rarely needed in animation, but interpolation can be fixed when some tools are applied. For example, if you don't have auto key on, and you move an object while on interpolated frame, the changes won't reset as they used to in an empty frame, but instead the gap between the keys is fixed. This is not usually needed in animation, except in the very late stage of work. It only signals that you have made a change without being in a key, so it would be better to set it back to one of the standard interpolation types. Also, empty frames actually have a special type of interpolation too, and this type is called step. In step, the intermediate positions between the keys are simply not calculated. There is another important topic related to tangents and Bezier interpolation: cycles. Let's do another short animation. This time I want the cube to move in a circle. In key 0 it will stay in the center of the scene. The next key will be in frame 10. I'll turn on trajectory tracking right away. The next one will be in frame 20, then in frame 30. And in frame 40 it has to go back to the initial position. So you can take the key in frame 0 and hold Shift and move it to frame 40. This way you can copy the key. Now I will set the Bezier interpolation. You can quickly limit the working area of the timeline to the last key by pressing this button. Now you can play the animation. The player has loop mode enabled. This means that the animation will be played endlessly, each time starting over. However, this is not the same as animation cycle. The first and the last frame are terminal, and the cube slows down as it moves toward them. And their tangents are such that the trajectory is more like a drop. A cycle is when the last frame transitions to the first. For a cycle, I need a smooth trajectory with no change in velocity. It should look as if there is a second to last key before the first key, and after the last one there would be the first one. But it is inconvenient and not necessary to create so many extra keys. Cascadeur offers a special tool for cycles. So, here is the initial animation. It is necessary to select all frames except the very last key, the one that is a copy of the first. Then you need to click on the button to create a cycle. Now it is real animation cycle. The cube no longer stops each time and moves in a circle. The interval with the cycle has a pink frame on the timeline. This cycle can be extended to any number of frames. And the changes I will make on the original interval will also apply to the entire loop. And the last thing I want to talk about in this video is the graph editor. It's not the most intuitive tool, and working in Cascadeur is comfortable enough even without it. Therefore, in this course we will rarely use this tool. But nevertheless, this is a popular tool in many 3D animation programs, so I will briefly talk about how it works. The graph editor window can be opened from the Window menu. Now you can select any point of the object. In the graph editor, the motion of the object is represented as a graph. Suppose I want to see how the object moved along the z-axis. The line goes down, which means that the coordinates on this axis are decreasing. You can also see the coordinate values in the Object Properties window. Similarly, you can track the movement on the y and x axis. Also, you can track the rotations. By moving the points in the graph editor, you can change the position of the object, but usually it is more convenient to do it directly in the viewport. That's all for now. I advise you to be sure to practice setting up the different types of interpolation, change the timings and spacing, and track trajectories. All of this forms the basis for creating animations.